ఈ వీడియోస్ మీ దాంట్లో సేవ్ అయిన వీడియోస్ అన్ని పంపించమని చెప్పే కదమ్మా. సో ఇంకా కొన్ని వీడియోస్ మిస్ అయినాయి నా దగ్గర. రోల్ నంబర్ 15 17 ఉందా ఒకటి. ఐ చెక్ దట్. ఆ వీడియో ఫార్వర్డ్ చేయలేదు నాకు. Okay, anyway, we'll see this later. Those who have, check again your Google Drive, then forward the videos. If you are there in your drive, so don't forward it. If simply forward it now, I may not able to download all those videos. What you can do is share it. Share in that drive. Open the drive, right click on that, share, click on share, and then provide this email ID. So whatever email ID I have in the classroom, you take that email ID and share for that email ID so that I can download it. Simply if you forward it now, so administrative rights for that video will lies with you, so I cannot download it. So better thing is, instead of simply forwarding the mail, just you share it the video so that I can download it here in my desktop. Anyway, so we'll start today's class. So today we are going to start new topic, which is riveted joints. So I think you have some knowledge about this riveted joints. You had drawn some of the joints in our CMDP course also. So here we require that knowledge here also. So what is riveted joints, and we'll see what are different types of joints. Then how you can find the efficiency of a riveted joint. Then we'll see when a riveted joint is also subjected to some eccentric loading. So then how we can design how we can find the diameter of the rivets required for that eccentric loading. So basically we'll discuss about all these things in our riveted joints. First we'll see what is a riveted joint, what are different types of riveted joints. Then we'll see what are various failure modes of a riveted joint. Then we'll discuss about how we can find the efficiency or the strength of a riveted joint. We are in other terms the efficiency of a riveted joints. Then we'll try to see the design of these riveted joints for a boiler shells. After that we'll move on to the riveted joints which are subjected to eccentric loading. In that case, how we can design the riveted joint. Okay, so these are the things what we are going to discuss in these riveted joints. So in that, first we will move on to the introduction. So in that introduction, if you take this riveted joint, it comes under permanent fastenings or permanent joints. Generally the joints are classified into two categories or two groups. One is called permanent joints, other one is called temporary joints. So here the difference is, suppose if you want to disassemble the joint, so without destroying, if you are able to disassemble the joint, then we will call it as a temporary or detachable joints. Whereas if it is not possible without destroying, if you cannot disassemble or you cannot separate the parts of the joint, then we can call it as a permanent joint or permanent fastening. So the examples for this permanent fastening is these riveted joints. The riveted joints, similarly welded joints. So those are the permanent fastenings or permanent joints. Then coming to this temporary joints, if you take bolted joints, so without destroying the component joining the joint through this bolt or nut, so if you are, I am able to disassemble them simply unlocking the bolt or nut joint. So similarly, if you take a cotter joints, what we discussed in that CMDF course, cotter joints, whether it is cotter and spigot or cotter and sleeve or cotter and gib, there also you can easily detach all the joints without destroying all the components. Similarly, you have a couple keys, couplings, all those joints, whatever may be there are temporary joints. Whereas coming to the permanent joints, you have riveting, welding, or something like soldering or braided joints comes under this permanent category. The permanent fastenings are those fastenings which cannot be disassembled without destroying the connecting components. So that means without destroying means without breaking down the connecting components, you cannot disassemble the joint. So then that will call it as a permanent fastening or permanent joint. The examples of permanent fastenings in order of the strength. So here they are written in the order. Order in the sense, order of the strength means here the strength is in ascending order. That means the strength is increasing if you go in this direction. So that means shoulder joint is having less strength when compared to the braided joints. Similarly, welded joints and riveted joints, something like that. So all this comes under permanent fastenings. That is shoulder joint or braided joint or welded joints or riveted joints. Then comes the temporary joints or detachable fastenings, are those fastenings which can be disassembled without destroying the connecting components. The examples of temporary fastenings are screw joints, that is nothing but your bolted connections, keys, cutters, pin and spline joints. So all these comes under temporary joints. Of course, we are going to discuss about both in our course. So we'll discuss about permanent joints. In that permanent joints, we are going to deal with welded and riveted joints. In case of temporary joints, we will discuss about screw joints, that is bolted joints. Then we have cutter joints in the syllabus. Okay. So then first we will consider these riveted joints. So we'll discuss about what are the. Okay. Later we'll discuss while studying about the welded joints. We may discuss what are the merits. So both the riveted joints and welded joints, they are permanent joints. So what are their relative merits and demerits, are nothing but relative advantages and disadvantages one upon the other. So those things we'll discuss while entering into the welded joints. So here we'll see some of the basic terminology what we are going to use in case of these riveted joints. So before that, so first of all we see what is the function of a riveted joint or a rivet, or what is the function of rivet in the riveted joint. So the function of rivets in the joint is to make a connection that has both strength as well as stiffness or tightness. I can call it as stiffness or I can call it as a tightness also. So you require strength in order to prevent the joint from the failure. So the requirement of riveted joint is it should provide the sufficient strength to the components. At the same time, it need to provide the tightness in the joint also. The strength requirement is to prevent the failure of the joint, whereas the tightness is necessary in order to contribute to the strength. So that means if the joint is tight, it will contribute towards the strength as well as preventing the leakage. In order to prevent the leakage, suppose if the joint is used in case of a boiler or a ship hull, so then leakage is going to be a big problem in that. So if the boiler is leaking means it cannot be operated with a leakage. Or similarly, in case of ship hull also, if it is leaking, so then you cannot sail the ship in the water. So because of that water leakage, it is going to drain into the water. So therefore, to prevent this leakage, if you want in such applications, your joint should prevent the leakage. So in that case, the tightness is also the important parameter in addition to the strength. Now, if I look at the rivet here, so this is the picture of the rivet. Here, the components are the various parts of this rivet says. We know this is called as a semi-cylindrical portion. So we'll call it as a head of the rivet, and then the portion. This is the portion which lies within the connecting parts. So this is the entire portion which will lie. Suppose if I connected two plates through this rivet joint, let us say it is a lap joint. Anyway, we'll see what is a lap joint. Something like this. So whatever portion there which lies within the connecting components, then we'll call that portion as a shank or body of the rivet. Then this is a tail. So this tail is again converted into a hemispherical. You can call it as a hemispherical surface. So either through cold working or hot working process. So we'll see that how we can convert this one is. Of course, we are not going to deal with those cold working and hot working processes. But only thing is, so here this portion here it is something like a first one of a cone, something like that. But this is converted into something like this hemispherical shape through either cold working or hot working process. So okay, that's what I showed it here. See here, this is the method of riveting or how riveting can be done. So again, there are two types of riveting methods: manual riveting and machine-made riveting. So either you can use manual or machine for the riveting process. So wherever you want better accuracy, so in that case we'll go for a better accuracy in the sense better strength and tightness. We'll go for the machine riveting, or else in all other than all other applications we go for hand riveting. So this is the process what we have shown. What I have shown here, it is a hand riveting process. So in that, so in order to prepare a riveting joint, so first you need to drill two holes into the connecting parts. So here this is one plate and this is another plate. So I want to join these two plates through riveted joint. So for that, first I will drill a hole in the two plates. So generally the diameter of this hole within this plate is more than the diameter of the rivet. So this is what I showed here, shank portion. So whatever may be the diameter at the shank portion, we call that one as the nominal diameter or simply the diameter of the rivet. So here, so if you know the diameter of the rivet, generally the size of the hole which we are drilling in the plate is more than 1.5 mm. Then that means the size of the hole is D plus 1.5 mm. We always a clearance should be provided. So why we need to provide the clearance means, so later while preparing the joint, so what we will do is whether it is a machine made or handmade joint. So here in this case it is a handmade process. Here in this you can see a die is placed on the rivet and then some compressive force is applied to this die, so that this whatever may be the tail portion is there. Earlier it is a first one of cone. Now it can be converted into a hemispherical space. So then, so while doing this, we are compressing this. So whenever you compress a component, its other dimension. So this dimension, that is the length is decreasing here. If the length is decreasing, automatically because of the Poisson's effect, in other direction the dimension will increase. So to accommodate that increase in the dimensions, here we are providing the clearance. Now you can see that after the joint is formed, the clearance is not there now. The clearance is closed here. So before the joint, from this picture you can clearly see that here you have a gap. Gap is nothing but a clearance. You can see the gap. But you are forcing this, or you are subjecting this rivet to the compressive force through this die. So why we are using this die means whatever shape of the die you get it is, your point will also have the same shape. If you use hemispherical die, you will get hemispherical. If you use rectangle, you will get rectangle, like that generally. So we'll show something like this only. So then the tail portion, after it is after the riveting process, what we got it as, we'll call it as a point. So this is edge and this is point. Even though both are looking similar, but they have different names. So now here, like I said here, if you apply a compressive force, so the rivet will be compressed so that its length will be decreased. So in this direction, it is going to be, the dimension of the rivet will increase. That means that the diameter is slightly more than the original diameter of the rivet. So such that this clearance will be closed. So generally the clearance is going to be 1.5 mm. Okay, so this is how we can see that the riveting joints are prepared. So the process is simple. First, what you need to do is you need to drill the holes in the two connecting plates. Then first you need to insert the rivet into that. So then, bottom on the bar to the head. This is the head of the rivet. So original head. So this head is supported by some backing up bar. Then on the tail side, a die will be placed on the tail, and a compressive force is applied to the die. So whether it is a cold working process or hot working process, so this will reduce, or gradually it will come and it will reduce the length of the rivet. That means it will reduce the tail portion of the rivet, such that it will also become a hemispherical body. So through this process, riveting can be done. So then we'll move on to what are different types of riveting joints. So again, the classification is, it is a general classification. So the classification may be made on different parameters, not only single parameter. If you say it is single parameter, it's not a complete classification, because in case of this riveted joints, there are so many parameters. So then there may be different types of classifications also. First is based on how you are connecting the plates. Depending upon the way in which the plates are connected, so the joints are classified into two categories. They are lap joint and butt joint. So lap joint is, I think, is it audible? Maybe I have a doubt.
Yes, sir. Yes, sir.
Okay. Yes. Okay. Right. So based on that, how the plates are connected, how the plates are joined. So the joints are classified into two categories. One is called lap joint, other one is butt joint. So this is what we'll call it as a lap joint. So in case of lap joint, so how the plates are connecting here? This is one plate and this is another plate, and these two plates are connected through the rivets here. See, if you look at this joint, this is the front view and this is the top view of the joint. So here also you can see that this is the bottom plate and this is the top plate. These two plates are connected through this rivet. So here it's not a single rivet. You have a row of rivets are there. So there are 4 rivets. So we'll call it as a row. So again, like I said, there may be another kind of classification based on the number of rows are there. Here you have a single row. You have only one row is there. So I'll call it as a single row lap joint. Suppose if I have more than one row, then if there are 2 rows, I'll call it as 2 row or double row lap joint. So if 3 rows are there, triple row lap joint, something like that. Based on number of rows also we can classify either it is single row or double row. One kind of classification is, first what we are discussing is lap joint and butt joint. So in case of lap joint, how these two plates are connected? One plate, lap in the sense, the meaning of the lap is nothing but overlap. So that means, see, the connecting plate should be overlap one upon other. So here this top plate is placed on the bottom plate, then the riveting is done here. So then this kind of joint, what we call it as a lap. Lap is nothing but overlap. So this plate is overlapping on the top plate is overlapping on the bottom plate. So we call it as a lap joint. Similarly, in case of butt joint, and also one more important point here you can remember here is, in case of lap joint, we don't use any additional cover plate. So only we want to join these two plates. So only those two plates are connected through the rivets. Whereas in case of butt joint, you require additional plate, which we will call it as a cover plate. You can see it here. So this is what we call it as a butt joint here. In case of butt joint, I have this is one plate and this is another plate. So I want to join these two plates. So to join these two plates, simply I cannot connect this one through the rivets, because here since there is a overlap, it is possible to join these two plates through the rivets. But here these two plates are not overlapping each other. They are kept side by side. So then that is the definition for this butt joint. So in case of butt joint, the plates are placed side by side. So that means they are touching each other. So if I want to join these two plates through rivets, it is not possible. So therefore, an additional plate which is covering these two plates, I will call it as cover plate. So that you require a cover plate in order to prepare the joint here. So now on these two plates, a cover plate is placed here. So then see, one row of rivets are there for the cover plate and this plate, and another row of rivets are there for the cover plate and this one. So then this is also, even though physically if you see that there are two rows of rivets are there, but if we talk about the number of rows in the butt joint, I'll say only single row. Here it is. In case of lap joint, we are calling it as a single row lap joint. Even this also I can call it as single row butt joint. Why I am calling it as, even though you have a two rows of rivets, why I am calling it as single row? See, if you look at for each plate, how many number of the rows are there? You need to look into that. If I see the lap joint here, for this plate there is one row of rivets. Even for this plate also there is one row of rivets. So that's why I'll call it as a single row. Here, if I come to the butt joint, so this is the front view and this is the top view of the butt joint. This particular butt joint here. See here, even for left side plate you have only one row, and for right side plate also you have only one row. So that means there is only one row for each plate to connecting they are connected by the joint. So then that's why we'll call it as single row butt joint only, not double row. Even though you can see that two rows are there in the diagram, but each row is corresponding to only single plate. So that means the left row is corresponding to the left plate and the right row is corresponding to the right plate only. So that's why even though there are two rows, we'll call it as single row butt joint only. So that is, so in case of butt joint, the difference between this lap joint and butt joint is, the first difference is, in case of the lap joint, you need to place one plate upon the other. You need to place one plate upon the other. Whereas in the case of butt joint, you need to keep the plates side by side. There is no overlapping is there in this. So in case of lap joint, you don't require any cover plate. Simply those two plates are connected through the rivets here. Whereas in case of butt joint, you required at least one cover plate. Maybe in some of the joints you have one more cover plate. Top and bottom also there is a cover plate. So then I'll call it as a double cover butt joint. So here it is only single cover is there. I'll call it as single cover butt joint. So single cover plate butt joint. So maybe some cases you may have double cover also there, even triple cover also there. So like that there will be different combinations are there. We'll call it this particular combination. So but here thing is, you require a cover plate. If you want to go for a butt joint, definitely you require the cover plate. In addition to the plates which are going to be joined, you require an additional plate which is called a cover plate. The number of cover plates may be 1, 2 or 3, something like that. That depends upon the joint. So so you need to look at, in order to identify how many number of rows are there for each joint in the joint. So you need to look at how many number of rows are there for each plate. So in this case here, in this particular case, there is only single row for each plate. So I'll call this one as a single row butt joint. Okay, so this is one kind of classification, that is only based on how the position of the plates. If you place one plate over the other, I'll call it as a lap joint. If I kept the two joining plates side by side, I'll call it as butt joint. Then comes whether it is single row or double row, or single cover plate or double cover plate, like that. There is another type of classification. That also we'll see. So now, so this is one kind of classification, that is how our plates are connected, that is either lap or butt. Then depending upon number of rows of rivets, you can classify it as single riveted lap joint. That means only single row is there in that, then we'll call it as a single riveted lap joint. Then you have double riveted lap joint. That means again in lap joint you have different types. That is, if there is only one row, I will call it as a single row or single riveted lap joint. If there are two rows, see here, you can see for each plate here, this is the top plate and this is the bottom plate. Two rivets are there in each plate. That means two rows of rivets are there in each plate. That's why I'll call it as double riveted lap joints. Why it is lap joint means one plate is placed upon the bottom plate. So the top plate is overlapped on the bottom plate. So that's why I'll call it as a lap joint, this one. Then this is another kind of the joint that we'll call it as double riveted lap joint. But the method of riveting here it is zigzag. So here in this case we'll call this one as a chain riveting, and this one we'll call it as a zigzag riveting. So what is the difference between chain riveting, or what is chain riveting, or what is zigzag riveting? If the rows are arranged in such a manner, so the rivets in the two rows are at the same location like this, they are parallel. If you see that these rivets are parallel to each other, our rivet center lines are, all the center lines are on the same line. So these are the rivets on the first row and these are the rivets on the second row. So now if I take a rivet on the first row and second row, their center lines are passing through the same line. So then if I take this one, their center lines are also same. Like this, here also the center line of these two rivets also same. So then this kind of riveting we call it as a chain riveting. If it is different from that, so here the center line for this rivet is something like this, for this rivet it is something like this. So it is something going like this, the center lines. So that's why we call it as a zigzag riveting. So, but both are double riveted joints only. Why both are double riveted joints? Because you have one row for this plate, even the second row is also for this plate. So each plate you have two rows here. So that's why it is called zigzag riveting. Then this is a butt joint. So, and also here, like I have mentioned here, so this is the plate and this is the part. These are the two plates which are getting connected through. This is one cover plate and this is another cover plate. So then that means here this is a butt joint. So with two double cover plates, that what you can call it as, and also single riveted. So why it is single riveted? There is only one row for each plate. So this is the row corresponding to this plate, and this is the row corresponding to this plate. So that means each plate has only one row here. So that's why I'll call it as single row. So then we can name this joint as single riveted double strap butt joint. Double strap means strap is nothing but a cover plate here. Double strap means here you can see that two cover plates are there. This is one cover plate and this is another cover plate. Again, you may have different things here. If you see that these two cover plates are of same length here, but sometimes you may have unequal cover plates also there. That means the length of the top cover plate or maybe the bottom cover plate may be different from the other one. So then in that case, we'll call it as unequal double strap butt joint, something like that we can call it. So again, these are the things which are based on the given specifications only. So how the joint is look like. So here, if I use two cover plates, I'll call it as double strap. If I use only one cover plate, I'll call it as a single strap. Something like that. See here again, these are also double strap only. This is also double strap and this is also double strap. But only thing is, here you have multiple rows. Here you have only single row. In this case, you have two rows. In this case also you have two rows. Again, the difference between these two is this is a chain riveting and this is a zigzag riveting. So that means this is another classification. So that is again in the double riveted, double strap, butt joint. Again in that you have a chain riveting as well as a zigzag riveting. Similarly, if I increase one more row in each joint here, that means if I place one more rivet here, then I'll call it as a triple riveted. So like that, you can increase the number of rows. So therefore, you will give a different name for the joint also. Okay, so that is okay. So you can see here, this is another kind of joint here, depending upon the number of rows of rivets. So that's what we are discussing here. There is single row, double row, single row, double row, double row. Again, this is a chain riveting, and these three bottom three are the butt joints and top three are the lap joints. So again, in the bottom three, you can see that it is single row. It is these two are double row butt joints. In the first one, in this case, we are using chain riveting. In this case, the zigzag riveting is used. Then you have another kind of, again, it is a butt joint. Like I already told here, if you see this in this joint, it is also double cover butt joint only, and also there are two rows are there. So I'll call it as double riveted butt joint only. So there are two rows means double row butt joint. But here, if you see the cover plate, the bottom cover plate is having this much length, whereas top cover plate has only this length only. So that means the length of the cover plate is not same. That is unequal. So that's why we'll give it as double riveted, because you have two rows are there. We'll call it as double riveted. Double strap means there are two straps are there. So we'll call it as double strap. Unequal. So why it is unequal? Because the lengths are not equal here. So that's why we'll call it as unequal butt joint with zigzag riveting. Here the type of riveting is zigzag. So you can see that all the center lines in the center line of rivets in all the rows is not same. So here it is going center line something like this. So this is zigzag kind of riveting. Whereas in case of chain riveting, you can see your center lines are all center lines are in same line. Okay, so like this, depending upon the number of rows and how the rivets are arranged in that row, in the rows, either you can classify it as single row, double row, or triple row, or chain riveting or zigzag riveting. So again, that is same for both lap joint as well as the butt joint. So you can have, in case of lap joint, you can have chain riveting or you can have zigzag riveting. But only thing is, when the number of rows are more than 2, then only you can go for, you can call it as either chain riveting or zigzag riveting. If there is only one row, you cannot say that it is a zigzag or chain riveting. But because there is only one row is there, when number of rows are more than 1, 2 or more than 1 means 2 or more, then you can specify that whether it is a chain riveting or zigzag riveting. Okay, so okay, right. So these are the different types of classifications. So first classification is based on how the connecting plates are connected, joint. So that is lap and butt. Then we classify based on the number of rows and also type of pattern. Here we call it, we have seen these are the two types of riveting, that is chain riveting and zigzag riveting. There is another kind of riveting also, we'll call it as a diamond riveting. So in case of most structural applications, we'll see the diamond riveting. If you see any railway bridge, if you observe any railway bridge which is nothing but a truss structure, so all those truss members are connected through these riveted joints only. You see, if you clearly observe that there, your joint will be something like this. All the rivets are joined in this, like this space, like this. So the cover plate shape is something like this. So your rivets will be only like this. In this, your rivets are goes on increasing something like this. Maybe I think I have that figure also. I'll show you later, sometime later. Why we call it as a diamond means because the shape of this thing is just like something like a diamond. That's why it is called a diamond riveting. So that means again it is a butt joint only, but in that butt joint again, or sometimes it may be lap joint also, but only thing here is so how the rivets are arranged here. So you can see here the rivets are in all the lines here. So but it is a zigzag. We are calling it as a zigzag because it is something like this. In case of a diamond riveting, there is a uniform pattern. That means the outermost row will have only one rivet, then the next row will have two rivets, then the next row will have three rivets, something like this. Then the next row will have four rivets. Like that, they will increase the number of rows from the outer rows to the, if I move on to the inner row, innermost row. So what is outer row, what is inner row here? If you look at this diagram here, I'll call this one as a outer row and I'll call this one as inner row in this case. So here, this is the end of the plate. So this is the end of this plate as well as this elbow, or you can say this is the starting of this plate as well as this plate. So therefore, this is the center line. I'll call it as the center line of the joint here. So now the row which is close to the center line, we call it as inner row, and the row which is away from the center line, we call it as the farthest one, we'll call it as outer row, and the closest one, we'll call it as inner row. Because here we have only two rows, so one is this will become inner row and this will become the outer row. But if I have one more row here, then in that case I'll call this one as the outer row and this one is inner row. You don't have any name for this. This simply I'll call it as a second row or something like that. This is first row, second row, third row, or this is inner row, this is second row, this is outer row. Like that we can call it. So outer row is nothing but the row of rivets which is farthest from the center line. If you take the center line here, so from the center line, if it is farthest, I'll call it as outer row. If it is closest, I'll call it as inner row. Similarly, this will call it as inner row and this will call it as outer row for this particular joint. Right? So this is how we can classify the rivets based on how they arrange, whether it is chain riveting or zigzag riveting or diamond riveting, maybe whether it is a butt joint or lap joint, or we can say if it is a butt joint or if it is a lap joint, how you are arranging the, in case of butt joint, how you are arranging the cover plate, whether it is a single cover plate or two cover plate joint. Again, if it is a two cover plate plates, is if the two cover plates are having same length or different length or unequal length, you need to specify like that. So this is about the brief classification of these riveted joints. So then we'll take up, there are two more methods or two more processes through which to make the joint is look in the beginning itself. While discussing about the purpose of a riveted joint is, the riveted joint should provide strength as well as tightness to the components. So here, to provide that tightness, so we'll use these two options. These two operations, what we'll call it as torquing or pullering. Only thing is, in this operation, what they'll do is here, these two at this point here, there is a possibility of leakage. So here, to remove that, so there are two different kind of tools are used here. So one is called caulking tool, or other one is called a pullering tool. So the difference between these two is only the edge thickness here. So, but here you can use it here or you can use it here. So using these two operations, what we are going to do here is the operation of burning down the edges of the plates and heads of the rivets to form a metal to metal joint. Pullering is the better option. So out of these two, pullering is the better option. He is saying that why pullering is the better option, because here you can see that the caulking tool, it is having a sharp edge here. So because of sharp edge, so it may destroy the plate sometimes. So or else because of sharp edge here, what happens is, for whatever may be the operation you perform here, because of that, here sharp corners are produced. If the sharp corner is there, we already discussed, whenever there is a sharp corners are there, because of the sharp corner, you have a stress concentration is there. To remove the stress concentration and also to make it is a fluid tight. Fluid tight means avoiding the leakage. We'll use these two options. Only thing is, in case of caulking and pullering, the difference is, here you have a tool which is having the width of the tool is more here when compared to this. That is the only thing. So, and also maybe the pullering angle here it is 80 degrees. Here it may be less than that, the angle. So angle doesn't matter here. Only thing is here the width of the tool, that is matters here. So if you take a sharp one here, that may damage the plates here. So that's why he said pullering is the better option. So using these two ways, so we can make the joint as a fluid tight. Right? Okay, so similarly, we have some more terminology what we are going to use in case of this riveted joints. First, we'll see those terminologies, then we'll move on to the actual design procedure of a joint. So, first one is pitch. The pitch, it is nothing but it is the distance from the center of one rivet to the center of the next rivet, measured parallel to the seam. So what is this parallel to the seam? What is the seam mean here? It is usually denoted by P. So that means, see, if I go back to the joint here, so this is the seam, what we call it as, this is the seam where you are connecting these two plates. So here we are making the joint at this location or center line. I can call it as seam or center line. So now, if we move along the center line, so then the distance between one row to the or the distance between the center lines of the two rivets, we call it as a pitch. So that may be either you can take these two rivets or you can take these two rivets. Here you have shown these two rivets. This is you have shown it as pitch. So or else you can take these two rivets also. This is also pitch only. So that means if you move along the seam of the joint, so the distance between the two center lines of the rivet, we'll call it as a pitch, and it is denoted by small p. So that's what is given here. It is the distance from the center of one rivet to the center of the next rivet. Immediately next you need to take. So don't take that distance between the two rivets means this rivet and this rivet. Don't say this is p. So what is this value? This is going to be 2p value because in between you have one more rivet. So up to this point this is p and this is also p. So you'll get 2p value. So you have to take two successive rivets only, not missing one rivet and taking the other next rivet. So you need to measure the pitch value between two successive or the distance between the two successive rivets in a row, in a single row along the seam. We'll call it as the pitch. We call it as a pitch of the rivet or riveted joints. Pitch of the riveted joint. Then we have one more definition, that is back pitch. So in case of single row, you don't have any back pitch values. Of course, pitch is there. If it is a single row riveted joint, you have a pitch, but you don't have back pitch. You will have only back pitch or diagonal pitch only in case of if the number of rows are more than 2. Then only you can define back pitch and diagonal pitch. So what is this back pitch? It is the perpendicular distance between the center lines of the successive rows. That means at least minimum if you have 2 rows, then only you can define this back pitch. Otherwise, you cannot define this back pitch. So now if I go back again here, see, has shown that back pitch anything? Yes, you can see here. So in case of single row rivet lap joint here, there is no back pitch. He has not shown anything here because at least minimum number of rows should be 2 in order to define the back pitch. So now here you have 2 rows are there. So then this is the center line and this is the center line of this row of rivets. Then the distance between the center lines of these 2 rivets is nothing but we call it as this distance is called as the back pitch. PB denoted by small p suffix b. Whereas this one is denoted by small p only. So that is the back pitch. Then you might see one more pitch, that is the diagonal pitch in the definition. You see here, you can see it here. You can see that this is what we call it as a diagonal pitch. That means this diagonal pitch can be defined in case of only zigzag riveting. In case of chain riveting, you cannot call this one as a diagonal pitch. Of course, you can call it, but only in case of chain riveting, we will define only this back pitch. Whereas in case of zigzag riveting, we'll call the distance between the distance between the center line of the 2 rivets and the 2 rows. We'll call this one as a diagonal pitch. So that's what here he defined that also. Diagonal pitch. It is the distance between the centers of rivet in adjacent rows of zigzag riveted joint. So this diagonal pitch can be defined when the rows are arranged in a zigzag pattern or zigzag manner. Whereas if the rivets are arranged in a chain riveting, then you can define the back pitch value. Right? So if there is only one row, then we can define only one pitch, that is single pitch, that is nominal pitch, or simply we call it as pitch. Whereas there are more than 2 rows, then if it is a chain riveting, you need to define back pitch. If it is a zigzag riveting, you need to define diagonal pitch. So again, this back pitch and diagonal pitch is nothing but the perpendicular distance between the center lines of 2 successive rows. Either it is a zigzag riveting or center line riveting. So it is usually this diagonal pitch is denoted by P suffix D. Then you have margin or marginal pitch. We'll call that as marginal pitch or margin. So it is nothing but it is the distance between the center of the rivet hole to the nearest edge of the plate. So that we'll call it as margin. So always in all riveted joints, there should be sufficient margin need to be provided in order to avoid the failure of the joint at the edge of the plate. So then that will call it as a margin pitch. So if I go back here, see here, maybe in this joint is not shown the margin here. I'll see here. Yes. So you can see here, this is the center line of the rivet and this is the edge of the plate. So then the distance between the center line of the rivet to the edge of the plate. So if it is only one rivet, I'll take that rivet only. So this we'll call it as marginal pitch or M. In case here, if you take this here, so then this is the edge of the plate and this is the center line. So this also I'll call it as margin M. Even for this also this distance, this is the edge of the plate and this is the row nearer to this edge. So then I'll call this one as margin. So like this, you can define the margin for all the things. So and also here, in case of double cover butt joint, if you have two double covers, so we'll take the thickness of one plate as T1 and we take the other thickness as T2. So therefore, these are the things what we need to follow while talking about the remaining topics in these riveted joints. Okay, and also here one more thing is in case of boiler joints, like I said, here if you see, this is another kind of riveted joints. So outer row will have only 2 rivets, inner row has 4 rivets here. Same thing here, it is a butt joint. You can clearly see that. So this is the seam or center line of the joint. So you can see that this is the front view of the joint. Here, this is what we'll call it as a seam. So generally the boilers are made using the seam joints or pressure vessels or boilers, whatever we call it as. So here this one what we'll call it as a seam. So here for the seam the rivets are there on the either side. You can clearly see that here either side there are rivets are there. So here while designing the joint or if you want to estimate what is the strength of the joint, so now I won't consider all the rivets in the joint. While finding out the strength or efficiency of the joint, what I need to do is I won't consider all the joints. So that's why we define here pitch is there, back pitch is there, and diagonal pitch is there, and also marginal pitch is also there. Of course, we'll consider all those things while defining the failure. But so instead of considering all the joints, then what we'll do is we'll use a repeating group. Generally, that is what we'll call it as a pitch. So here, this is the pitch length. This is the pitch length in this particular joint. If we take, so in this pitch length, so always I'll find the strength of the joint based on the pitch length only. So now, whatever may be the group within that pitch length, so it is going to repeat now onwards. If you see, look at the all other joints also. See here. Okay, I'll erase all these things. Then you can see that. Okay, see now you can see that. So this is the pitch length. This is the repeating section in this case. So the same thing is repeating now onwards. If I go on adding the rivets, it is going to be same. Similarly, here, if I take the repeating group, this is going to be the repeating group. This is going to be the repeating group. So now this is one group and this is another group. Like that, the joint will extend further. Something like that. So that's why always. So in this case here, this is going to be the repeating group. So now it is going to repeat again and again something. So see, this is going to be another group and this is going to be another group, something like that. It will extend. The joint is like this. So always we will find the strength of the joint based on the repeating groups only. So here for this case we can easily identify the repeating group, that is nothing but only the pitch length. Within the pitch length, how many number of rows are there? So we need to consider that. So then we'll consider strength of only those rivets for defining the strength of the joint, not all the rivets. So similarly here also this is one repeating group. So then this is another, something like that. You can take the repeating groups. So that's what I am showing it here in this one also. In case of boiler joints, the joints will be something like this. It is a special joint. In case of boilers, the joint is prepared something like this only, not a chain riveting or not a zigzag riveting. It is, of course, it is a zigzag riveting only. But here, outer rows is having larger pitch when compared to the inner rows. See here, this is the pitch value. That is twice the pitch here. You can say it is 2p. If I take this one, this distance is p. This is going to be 2p value. So that means a special kind of joint is used in case of boiler joints. So of course that depends upon the application again. So anyway, so here my intention to showing this picture is we should know that. So what is the repeating group of the particular joint? So based on that only we are able to find the, or we are going to find the strength of the joint. That is the important point what you need to remember. Okay, so this is another one, another type of joint here. You have 3 rows are there here. So 3 rows are there. In these 3 rows also again you need to consider what is the repeating section. So that means this is the pitch length. If I consider this is the outer pitch. This is from this rivet to this is the outer row pitch length here. In this pitch length, I need to consider this entire thing. What is the repeating group is something like this. So the same thing is repeating now onwards. See now, this is there, this is there. So now this is going to be our next repeating group. Like that, we need to identify what is the repeating group for each joint. Then your if you want to estimate the efficiency of the joint, you need to use this repeating section. Or if you want to find what is the strength of the joint also, you need to use this repeating groups. So here also again it is a butt joint only. So there are 3 rows are there in this. So you can clearly see that in the joint there are 3 rows are there. So we'll call it as triple row butt joint with 2 unequal. Say cover plates are also having unequal lengths here. So unequal cover plates with 3 number of rows for each plate. So for the top plate it is 3 rows. Even for bottom plate also there are 3 rows of rivets are there. But the riveting space is different. The pitch is different between from the inner row. This is the inner row and this is the outer row. See here the pitch value is for inner row. If you compare the inner row to the outer row pitch length is double when compared to the inner row. So why? Because so generally they will do like this, because if I go like this, so this is the edge of the plate. So if I go for more number of rivets here, so that means I need to drill more number of holes here. Since this point is close to this edge of the plate, so it will weaken the joint. So if I have more number, see, in order to prepare any joint, riveted joint, first I need to drill the holes in the plate. So therefore the plate will become weaker and weaker because it is edge where you are applying the load. Here this is the location which is close to your load application. That's why to reduce that, what they will do is in the outer row the pitch is different when compared to the pitch in the inner rows. Okay, so so anyway, this we already discussed. This is inner cover plate and this is the outer cover plate. In case of joint, in case of boiler joints, so we'll call it as inner and outer cover plate and inner cover plate. So then you may have other type of joints which I call it as a structural joints. So these are the most possible applications for this riveted joints. One application is in case of boilers, we'll use this riveted joints. So we'll call it as a boiler joint. So you are seeing 2 types of joints in that case. This is one type of joint and this is the other type of joint. Then you have a structural application. In case of structural application, like I already told, if you look at the railway bridges or for that matter, any bridge, most of the cases railway bridge. Your railway bridge is something like it is a truss structure only. So now here at this location, the joints, these members, or wherever the member is there, these 2 members, any 2 members are connected through riveted joints only. Here you have a joint, here you have a joint, here you have a joint. Similarly here, even at this location also you have a joint. Like that. Whenever there is if you want to connect 2 members in the truss, you need to use riveted joint also. So this is another application of the riveted joint, that is in case of structural joints. See now, okay, like I already mentioned here, this is what we call it as a diamond riveting. So in case of this diamond riveting, clearly you can see that Outermost row has only one row, one rivet. Then second row is 2 rivets, third row 3 rivets, fourth row 4 rivets. Like that, if you move from the outer row to the inner towards inner row, the number of rivets in a row will increase uniformly. That increase also uniformly. So then only we'll call it as a diamond riveting. Okay. So generally this kind of joint you'll use in case of these structural joints. In case of the structural joints, this type of joint is going to be used. This type of joint, what we call it as a diamond riveting. Okay, right. So then, okay, here also you can see that a repeating section. If you want to consider the repeating section, you can do that. So you can consider the repeating section here, and then again that joint strength is defined based on the repeating section only. But see here, okay, this P is the width of the plate. Okay, don't bother about that P and that P. Don't confuse between those two. Okay. Then, okay, I think this we already discussed. That is multiple rows. So here, this is a butt joint which is having a single row butt joint. This is a single row, and this is a double row butt joint. So in case of single row butt joint, this is the repeating section only. Then in case of this double row, it is going to be the repeating section. The repeating section means only I have to consider one rivet here. I need to consider 3 rivets here. So then, okay, similarly, I think we already seen this. Maybe it is repeating again here. It is a triple row butt joint pressure type. So in case of boilers, this type of joint is going to be used. Hello? Sir. క్లాసులో అని చెప్తున్నా గ్లౌజ్ లేదు అదేదో ఆర్డర్ ఇద్దాం అనుకోని మర్చిపోయా నేను సరే తీసుకున్నాను క్లాస్లో ఉన్నా నేను మళ్ళీ మాట్లాడతాను ఓకే సో దిస్ ఈజ్ ఏ ట్రిపుల్ riveted triple row butt joint. So in this case also we need to consider the repeating group to design the joint or to find the efficiency of the joint. So then here this is a quadruple row butt joint. So that means there are 4 rows in the joint. So 1 row, second row, third row, fourth row. Right? So you can observe that here. One thing what you can observe is if you move from the inner row to the outer row, the pitch is increasing. Or in other words, if you move from outer row to inner row, the pitch length is decreasing. So that you need to remember. So this is a standard pattern how we are going to design the joint. Okay, so same thing, the same joint here, whatever it is there here, that is shown in a enlarged view here. Maybe everything is same. So here, whatever this joint is there, this is shown in a enlarged view here. So this is also a quadruple. How many cover plates are there? 2 cover plates are there. So it is a butt joint having 2 cover plates having unequal lengths here. Maybe in the previous one, you have here also the same thing. Maybe you want to show some more parameters here in this. Okay, so here this is called short pitch, then medium pitch or intermediate pitch, then long pitch. So if you have something like this, here you have 3 pitch values. Short pitch means the smallest value. Like I already told, if you move from the inner row to outer row, the pitch is increasing. So at the inner row, this you can take this one or this one, both are same only. Here this is, you can call this one as a short pitch or even this one also short pitch. So these 2 values are same only. This pitch and this pitch, the distance between these 2 rivets and these 2 rivets is same. So that's why it is called short pitch. Then you have a intermediate pitch and you have a long pitch. That means if this type of joint is there, we need to define 3 pitch values, not only one single pitch. You need to define 3 pitch values also. Okay, and also anyway, this is the back pitch. We know that back pitch. So back pitch is nothing but the distance between 2 rows of rivets. So this is 1 row of rivet and this is another row of rivet. The perpendicular distance between these 2 rows of rivets is nothing but the back pitch value. Then see, you can see that here you have a diagonal pitch also in this joint. So all the things are there here if you look at this. So this is a diagonal joint. So diagonal pitch, this will call it as because you have a zigzag riveting here, something like this. For this portion only you have a zigzag riveting. So that's why you need to define this diagonal pitch also. That means whatever pitch is there, all things are covered in this particular figure. You have three normal pitches. So that means three different types of pitches. This is short pitch, intermediate pitch, and long pitch. And then this is the back pitch, and this is the diagonal pitch. Okay. I think so. This is the basic introduction what we need to know before going to estimate the strength of the joint, whether it is a lap joint or butt joint, or before going to see what are the various. So of course, before estimating the strength of the joint, we want to what do you say? We want to discuss about the in what way the joint is going to fail, or what are the different modes of failure modes of a riveted joint. First, we'll discuss that. So then, based on those failure modes only, we are able to find out its strength. So, like if it is the plate is failing because of tearing, so then what is the tensile strength of the joint? Or if the rivet is the joint is failed by shearing of the rivet, then in that case, what is the shearing strength of the joint? Or sometimes the plate may be, or the joint may be failed because of the crushing of the plate. So then, what is the crushing strength of the joint? So like that, we'll estimate first what are the different strengths of the joints. Then based on that, we are going to identify what is the final strength of the joint. So based on these three values, after that we'll define the efficiency of the joint also. Maybe we'll take up that one in the next class. So today, as far as this riveted joints is concerned, I'll stop at this point now. Maybe in the next 10 to 15 minutes, what we'll do is we'll take up a discussion class. So to discuss your doubts in some of maybe your doubts up to whatever we discuss. That is the first unit or second unit, whatever we discuss it. So if you have any doubt in those units, so we'll discuss your doubts. Maybe the problems what I have given to you for the practice, or maybe doubt maybe from any other thing. So which is related to those 2 units of syllabus. Okay, so right now I'm stopping here. So now you can ask your doubts. Maybe if you have a doubt in this particular class also, now you can ask. That is not an issue. But only thing is, first we'll focus on the previous 2 units of syllabus. So we'll discuss if you have any doubt in those things. Then if you have any doubt in this, we'll move on to this. So you can go ahead with your questions or queries, whatever you have, you can ask it now. But don't sit simply idly. So you utilize this, because maybe next week, I think you have mid examinations from next week onwards, right?
Yes,
I think
sir.
so. So then that means at least now onwards you need to start preparing for the examination. Otherwise you can't do anything. So if you prepare, then only you can ask the doubts. So that's why I already told you in the previous class itself, we'll conduct the discussions or doubts clarification in this hour or in this period. So I think if I announce something like that, you may come up with some doubts. Even still, if you are not asking any doubt, means you are not at all working on the subject, or not at all. Simply you are attending the class and you are throwing the notebook or whatever you have to the corner, and then simply you are enjoying it. So you are not preparing anything else. Okay, and also one more thing here is whatever joints in the riveted joints class. So today we discussed all those things are available in our what you can say data book. So in the data book, all those things are there. So no need to remember all those things also. So I think all those joints are there in the data book. So now first we'll do this one. Later we come to the doubts. Now those who are having a data book, just you open your data book and look into the chapter named it as riveted joints will be there. So in my data book it is 9th chapter. I don't know what is it is a old edition. I think this is a old edition. Maybe for you it may be different. Just in the content of the book, you will go through that. So you can see a topic on chapter 9 in my book. Chapter 9, riveted joints. So you may have your own, maybe if it is a new edition, The number may change, but definitely it will be there. Okay, just you open that. If you have data book with you, just you open that. So I'll tell you what are the things which are going to be used in case of course, previous thing is over now. So for this riveted joints, how we can use this data book? So I'll tell you that. So first of all, just open the data book. See in the data book, so you can see that if you open the riveted joints chapter, first he has given the symbols. So that means what is the symbol, for what purpose each symbol is used. Here you can see that D dash is there, D is there, LS is there. So that means that's what we already discussed in case of in the beginning. That is, if I shown to you a rivet, in that D dash is the normal diameter of the rivet. That means that D dash is nothing but the diameter of the rivet before making the riveted joint. Like I already told that after the riveting process, the diameter of the rivet is slightly increased. That is around 1.5 because you are providing a clearance between the plate hole and the rivet. So therefore, that clearance is filled after the joint is formed. So therefore, that's why you have two diameters. That's why he has given two things here. D dash is the nominal diameter of the rivet. That is diameter of the rivet before riveting, which is generally expressed in terms of mm. Then you have a D. D is gross diameter of the rivet. That is diameter of the rivet after riveting. So your D dash is less than D, and the relation is your D dash is generally 1.5 times D dash is D minus 1.5. You need to take like that. Similarly, LH is length of the shank portion. That is length of the shank portion means the shank is nothing but the portion which will insert into the two plates, or that is equivalent to the thickness of that, sum of the thickness of the two plates. You can say that. So then for boiler and axially loaded structural joints, so these are the terminologies they are used. Small t is thickness of the plate, and capital D internal diameter of the boiler. Capital P is pressure of steam inside the boiler expressed in terms of Newton per mm square. Our applied load is in newtons. Small p is pitch of the rivet in mm. Pb is back pitch, or we will call that one as a transverse pitch also, which is also expressed in mm. Pd diagonal pitch, which is also expressed in mm. M is margin, that is also expressed in mm. So these things we already discussed. P, Pb, Pd and M we already discussed just by looking at the joints. Already explained to you what is P, what is Pb, what is Pd also. So he is also using the same terminology here also, the same thing. Then capital F is strength of the solid plate. Like that, Ft tensile strength of the perforated plate. That is nothing but the perforated means the plate which is having some sort of hole or notch or something, whatever may be, some sort of material discontinuity is there. We call it as a perforated plate. Then Fs is shear strength of rivet expressed in newtons. Fc crushing strength of the rivets. St tensile stress. See here may be different. This may be different for you. So in my book it is sigma t. Actually normal stress will express in terms of sigma. In this particular book, this is a old edition. In the old edition they take it as St. Maybe in the new edition we have only sigma t only. Sigma t is for tensile stress for the plate. Tau s is the shear stress for the rivet. Sigma c is crushing stress for the rivet. All are expressed in Newton per mm square or MPa. Then T1 is used for the thickness of the cover plate, and eta is for the efficiency of the joint, riveted joint. Eta suffix L is efficiency of the longitudinal joint for a boiler. Eta C suffix C is nothing but efficiency of the circumferential joints. So these are the terminologies what you are going to use in case of these riveted joints. So then you have for eccentrically loaded structural joints. In that case, again there is some terminology is there. F, capital F, applied eccentric load, which is expressed in newtons. FP, induced primary load, a capital F suffix P, that is induced primary load, which is expressed in newtons. Similarly, Fs, R is nothing but the resultant of Fp and Fs. Then E is the eccentricity, X bar and Y bar. X bar means X coordinate of CZ, center of gravity of the riveted joint. Y bar, similarly, theta is the angle between primary and secondary loads in degrees. So those are the parameters what we are going to come across in the design of these riveted joints. Then you can see that in the next page we have design particulars on one side, that is the first column, and second column is equations are there. So in that he has given for boilers and axially loaded structural joints, he has given some formulas. So here this unwin formula is there, that is very important. So always we'll use in unwin's formula to find out the D of a rivet, that is nominal diameter of the rivet. So similarly in case of boiler, what is the formula for the thickness of the boiler plate, something like that. He has given all the formulas. So similarly, length of the rivet shank, he has given some definition for that. So then minimum pitch, that is nothing but, so for in case of in these joints, you need to define the pitch value. There should be some minimum value for the pitch, otherwise the joint is not stable. So that means it is not going to be the stable joint. So therefore you need to provide minimum pitch value and maximum perpendicular pitch also. He has given one more condition. So that means while designing the joint, you cannot take the pitch value as per your convenience. So you need to follow some regulations. So your pitch should be within these two. So it has to satisfy the minimum pitch condition as well as the maximum pitch condition. So then only, based on that only, you can identify the pitch value. Right? So I don't know how many of you having data book, are you looking into the data book?
Yes, sir.
How many? I don't know. Okay. So similarly, if we go to the next page, he has given two different types of riveting, that is chain riveting and zigzag riveting. So he has defined the PV value. So that means how much back pitch should be there per joint. So your PB should be greater than or equal to 2D in case of chain riveting. Whereas in case of zigzag riveting, it should be greater than 0.33P plus 0.67D. Like that, he has given the rivets. So when there are equal number of rivets in all rows, when there are equal number of rivets in the outer row is half of the number of rivets in the inner row. Like what we see in case of boiler joints. Boiler joint, I shown outer row we have only 2 rivets. So inner row we have 4 rivets. So that means the pitch will become double. So that's why here the number of rivets in the outer row is half of the number of rivets in the inner row. So in that case, we need to use different PP values. Back pitch will be different in that case also. So here these are the standards. As from the design data book, you need to follow these things only. So based on that, you need to pick the values. Similarly, he has given the formulas for thickness of the cover plates in case of a butt joint. If it is a single cover plate, your T1 is nothing but 1.125T, where T is the thickness of the plate itself. Then double cover plate, it is 0.625T. Similarly, for single cover plate with outermost row having alternative rivets. So that means the pitch is different in the outer row. So then you have to use different formula for that. Similarly, for in case of double cover plate, you have to use some other formula. For wide cover plate placed inside the boiler. So that means, like I shown the joint. So in that case, one is having unequal lengths. If the wide cover plate is inside, you have to use one formula. If the wide cover plate is outside, you have to use another formula. So that's what he has given here. Wide cover plate placed inside the boiler, T1 is 0.75D. For narrow cover plate placed outside the boiler, you have to use T1 is 0.625D. Similarly, all the joints always, in case of whatever may be the type of joint, always the margin should be 1.5D. So that you have to remember. Then, if you go to the next page, so he has given the pictures of the joints also. See, first joint what he has given is triple riveted double strap unequal butt joint. So what we have already seen that. So now sometimes what happens is in the examination they may ask draw so and so joint. So If you don't know that, so how to use the data book, then you are unable to do it. So if you know where it is there, then you can simply open the data book and you can copy it from in the examination. So that means with the data book, you can do some sort of copying also, without reading or without knowing. But only thing you should know is that whether that particular thing is there in the data book or not, or if it is there, how we can access that. That you should know. If you know that, what are the things available in the data book, then no need to study all those things. So if something comes in the examination about that particular thing, simply you can copy it. Nobody will question you because officially the data book is allowed in the examination. So nobody will argue with you also. So you can copy there. So just by copying something from the data book also you will get the marks and you can pass the examination. So that's why I'm insisting on you need to buy the data book. So otherwise, if you don't know now, so here the only thing is if you are regularly using the data book, then you will know what is there wherever it is there. Suppose if I want to talk about the riveted joints, you can easily access that in the data book. In the examination, so you cannot turn on all the pages. Let us say in the book there are 1,000 pages are there. You cannot turn up all the 1,000 pages. So if you do like that, just to turn all those 1,000 pages only, your 3 hours time will be over. So that's why simply you need to know that what are the content of your data book or how you can use the data book for your examination. That is also important. Okay, so that is one joint. Similarly, you can see that other joints are also there. So lap joint is there. First one is butt joint. Then you have a lap joint is also there. In case of lap joint, you have both the things. That is chain riveting is there and zigzag riveting is there. So he has given the joint and the next page for each joint he has given the design equations also. So that means no need to mug up. The only thing is you need to know how you have to use these equations. That is the only thing you need to follow. So once he has already given all the equations, just you need to use the equations to design the given joint. That is the only thing you need to do. So similarly, diamond joint is also there. If you go for the next page, we have a diamond riveted joint is also there. For that also he has given all the design particulars and design equations also. So only thing is you need to pick all those formulas from the data book. So based on that you need to design your joint. So that is the thing what you need to do. Similarly, not only that, even in case of eccentric loading also, if I go for the next page, he has given the formulas for how we can design the joint for the eccentric loading also. So that also is given how we can compute what is the primary force and what is the secondary force, and then from the primary and secondary force how we can calculate the resultant force. Then from that how we can estimate the diameter of the rivet required also. Those things are also given in the data book. So only thing is you should have a data book first thing, then you should know how to use the data book. That is also another important thing. Then after that he has given the different types of rivet heads also. Maybe sometimes they may ask in the examination, draw so and so rivet. So snap head or pan head or mushroom head or something like that. With proportions it has given in the data book. So if such kind of question comes, maybe it is for 2 marks or 1 mark. Maybe most probably 2 marks questions are there. Under 2 marks question, there may be a chance of getting a question something like that. So then in that case, you can simply copy it from the data book so that you will get those 2 marks. So that's why your data book is very, very important. Similarly, so if you go through the other pages also, some more values are there. Depending upon the type of joint, whether it is single riveted or single cover plate or double cover plate, or single riveted or multiple riveted, something like that. So based on that, here this is important in all of our data book. The first important thing is table 9.5. So we most frequently use this table 9.5 because to identify the nominal diameter of the rivet. So the final answer, if you want to design any riveted joint, you need to find out what is the nominal diameter of the rivet. So using calculations I will get something, but if I want to standardize it, so I need to use the standard diameter for the joint. So those standard diameters you get from only this table 9.5. So here in the table 9.5 has given nominal diameter of the rivet as well as the diameter of the rivet hole also. See, I said it is usually the difference between those two is 1.5 mm, but it is not uniform for all the cases. So if you see that The first column is 12 and 13. That is the difference is 1. Then you have 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Up to 24, there is only 1 mm gap. So if you go for 27, then you have 27, 28.5, 30, 31.5, 33, 34.5, 36, 37.5, 39. Then beyond 36, it is 39 and 41. Now the clearance is 2 mm, not 1.5 mm also. 42, 44, 48, 50, something like that. So if you go through the data book, you can understand all these things. Okay. Similarly, you have one more thing here. Boiler code factor is there. C. So in problems, will encounter this one. Or else, if you come back to the first page of that, so there we specify that the minimum pitch and maximum pitch. To estimate the maximum pitch value, you need to have this boiler code factor C. So that is all that you will get from this table 9.7. Like that. So if you go to the next page, then characteristics of strong structural joints is given like that. So then what are the things are? So that means if you want to make the joint is strong, so these are the recommendations for our joint. If it is a lap joint, so again in lap joint, if it is a single riveted or double riveted or triple riveted, so the diameter of the rivet should be 2 times the thickness. So then similarly the pitch should be, minimum pitch should be either 3D, 4D or 5D. Like that he has given all the specifications. And also the efficiency of if you follow these specifications, the efficiency of the joint is going to be maybe 50 to 60%. In case of single riveted, in case of double riveted, it is 60 to 75%. In case of triple riveted lap joint, it is 70 to 80%. So that means, so if your requirement is, if you want to design a joint for 70 to 80% or within that range, or let us say 75% efficiency, then which type of joint you need to pick. Sometimes they make you a question like that also. So then that you can identify only from the data book. That means if I go for double riveted, so the maximum efficiency is only 75. So I cannot go for double riveted lap joint. I will go for triple riveted. So then the maximum possible efficiency for in case of a triple riveted lap joint is 80%. So then I can go for that. Similarly, if I want to go for a butt joint having a specified efficiency, that is let us say 80% efficiency, then in that case I can go for triple riveted, equal width straps, or triple riveted unequal width straps also. Like that. So you need to first decide what is the type of the joint you need to use. Then based on the joint you need to design the again. So that means design in the sense you need to specify what is the different pitch values, what are the margin values, and what are the diameter of the rivets. So those things you need to define. Right? So similarly, okay, so in the last page, that is 9.22 in my book. So it is recommended values of allowable stress for structural joints. You can see that tensile stress, shear stress, and constriction. So sometimes what they will say is in the examination, they will use some application and they will ask design a riveted joint for this application. Simply they will say like that. So in that case, you should know what are the allowable stress. Like I said earlier, suppose if I give some material 40 C8. So if I simply say the component is made of 40 C8, then if I want to design the component for the static failure or maybe fading failure. If it is a static failure, I require ST, SUT and SYT. If that is not given in the problem, then what I have to do? I have to refer the data book. In the data book, you will get those properties, SUT and SYT. Similarly, in case of these riveted joints, so the allowable tensile stress and the allowable compressive stress or pressing stress or the allowable shear stress is if it is mentioned in the problem, it's okay, right? So if it is not given, then again that data need to be picked from the data book only. So like this, so all the things here is the riveted joints is most of the problems. If you don't know how to use the data book, you are not able to solve the problem. So the important thing here is the data book. Without data book, you cannot solve the problem. That is the thing you need to write it. So make sure that if you are not bought the, even till now, if you didn't bought the data book, try to buy it now itself so that it will be useful for you. So semester anta ayipina konte upayogam. So it is useless also. If you are not using that, so at the end of the semester, for the sake of buying the book, if you buy it, it is useless. So anyway, if you want to fix it, so if you want to buy it, just buy it. Those who don't have a data book, you try to buy it now. So otherwise, it is going to be very difficult for you to follow the class also, because everything in the case of this riveted joint, everything is related to, or every problem is connected with the data from the data book only. So it is must, data book is must not to progress in this topic, riveted joints. Not only riveted joints, even in case of welded joints also require data book. Right? So this is the thing what I want to say about usage of this data book. So, okay. So I think now we come to your queries and questions. So it is 4:41. If required, I'll extend required. Maybe if you have any doubt, write down. I think you are not going to ask from your what you can say from the response. What I can understand is you are not going to ask any question. That is for sure. If somebody is asked, then okay. So simply we may follow it or not. Simply we sit idle, something like that. Okay. So only I think only 51 members are joined today's class out of 64. I don't know what happened to the remaining people. So simply they joined and they left it. Okay. Anyway, you are going to get the attendance now. So I think I'll place that link also. I have not put so far. I'll put that link also. Meantime, so you ready with your queries or questions or whatever, maybe doubts, whatever you want.
సార్ వాళ్ళది ఏం పోస్ట్ చేయాలి సార్ హోంవర్క్కి?
ఏంటది?
అటెండెన్స్కి ఏం పోస్ట్ చేయాలి సార్? వాళ్ళ జస్ట్ ఈ రఫ్ నోట్స్ వరకు పోస్ట్ చేస్తే చాలా సార్.
ఏంటమ్మా?
రఫ్ వర్క్ వరకు పోస్ట్ చేస్తే చాలా.
ఇవాళ సంశయం చేయలేదు కదా సార్?
ఇవాళ
క్యాలిక్యులేషన్స్ ఏం చేయలేదు కదా సార్ ఇవాళ? రన్నింగ్ నోట్స్
అంతమంది చెప్పింది థియరిటికల్ కాన్సెప్ట్ లేక క్యాలిక్యులేషన్ ఏమున్నాయి ఇక్కడ ఇవాళ?
అదే సార్, అంటే ఏం పోస్ట్ చేయమంటారు వాళ్ళకి?
అరే నేను ఏం పోస్ట్ చేయమన్నా? క్లాస్ నోట్సే కదా పోస్ట్ చేయమని. నేను ఏ రాసావో అదే పోస్ట్ చెయ్యి.
సరే సార్.
నువ్వు ఈ క్లాస్ జరుగుతున్నప్పుడు ఏం నోట్ చేసావో దాన్ని పోస్ట్ చేయరా బాబు. అది వేరే వాళ్ళు ఎవరు చూడలేదు, వేరే వాళ్ళకి చూపించలే నేను.
చూపిస్తారా? అసలు సైడ్ హెడ్డింగ్స్ తప్పితే ఏం రాయలేదు సార్.
అదే లోడ్ చేయరా, అదే అప్లోడ్ చేయరా. నువ్వు క్లాస్ అంతవరకే ఫాలో అవుతున్నా అనుకుంటా నేను చూసి. అంతకంటే ఇది చేయగలిగింది ఏముంది? మీ దగ్గర ఏ మెటీరియల్ ఉందో అదే అప్లోడ్ చేయి. దట్ ఈస్ ద కరెక్ట్ వే. అంత కాకుండా నేను ఓన్లీ సైడ్ నోట్స్ రాసే ఇది బాగాలేదు అని చెప్పేసి వేరే వాడికి వాట్సాప్లో తెప్పించుకొని దాన్ని అప్లోడ్ చేయడం వల్ల ఉపయోగం లేదు. నువ్వే రాసేవో అదే అప్లోడ్ చేయి. అది 1 లైనా 2 లైన్లా 4 లైన్లా ఇంకెంత అయినా సరే ఇట్ డజంట్ మ్యాటర్. సో కాకపోతే ఏంటంటే నేను ఎప్పుడైనా దాన్ని ఓపెన్ చేసి చూస్తే ఓకే ఈ క్లాస్ ఇట్లానే ఫాలో అవుతున్నాడు అని నేను అర్థం చేసుకుంటాను అంతే. ఓకే
ఓకే సార్.
ఓకే సార్.
రైట్. సో యా టెల్ మీ.
పీడిఎఫ్ పెడతారా సార్?
పీడిఎఫ్ ఏంట్రా?
సిలబస్ సార్, అదే యూనిట్ 1 టు ది
యూనిట్ 1
టు సార్ పీడిఎఫ్ సార్ మొత్తం. అంటే
పవర్ పాయింట్ ప్రజెంటేషన్?
అవును సార్.
పవర్ పాయింట్ ప్రజెంటేషన్ ఎందుకు నీకు?
అంటే నోట్స్ లో అందరి అన్ని కంప్లీట్ గా లేవు కదా సార్. డెఫినేషన్లు అయినా ఇప్పుడు చూసుకుని ఇప్పుడు రాసిన అయినా డయాగ్రామ్స్ లేవు కదా సార్ అందులో.
అవునమ్మా, నీకు టెక్స్ట్ బుక్ లేదా నీ దగ్గర?
లేదు సార్.
ఒరే టెక్స్ట్ బుక్ లేకుండా ఏం ప్రిపేర్ అవుతున్నా మీరు?
డేటా బుక్
లేదు, క్లాస్ నోట్స్ సరిగ్గా రాయము, మరి ఎట్లా ప్రిపేర్ అవుతారు రేపు ఎగ్జామ్కి? ఇదంతా పీపీడీలో అంతా ఉండదు కదా. నేను చెప్పింది అంతా ఉండకపోవచ్చు పీపీడీలో. పీపీడీలో ఒకసారి ఏంటంటే బుల్లెట్స్ లాగా కొన్ని పాయింట్స్ లాగా ఉంటుంది కదా పీపీటీ. సో దాంట్లో అంత ఎక్స్ప్లెనేషన్ ఉండకపోవచ్చు కదా. చూస్తాను, వీలైతే షేర్ చేస్తాను. మేబీ ఆ డిపార్ట్మెంట్లో డిసిషన్ తీసుకోవాలనుకుంటా దాని గురించి. ఆ షేర్ చేయండి అంటే షేర్ చేస్తాను. డిపార్ట్మెంట్ వాళ్ళు పీపీటీ మామూలుగా వీడియోలు ఇవి షేర్ చేయొద్దని చెప్పారు. మామూలుగా ఉన్నాయి ఓవరాల్గా ఉన్న ఇన్స్ట్రక్షన్ అయితే అది. లేదు షేర్ చేయొచ్చు అనుకుంటే నేను షేర్ చేస్తాను, నాకే అభ్యంతరం లేదు. నా దగ్గర ఉంది దాంట్లో క్లాస్ రూమ్లో పెట్టమే కదా
సార్. వీడియోలు అక్కర్లేదు సార్.
వీడియోలు కాదు సార్, మామూలు కాన్సెప్ట్స్ అయ్యే అవే సార్. అంటే వేరే సబ్జెక్ట్ లో కూడా పెట్టారు సార్.
వేరే సబ్జెక్టులు షేర్ చేశారా మీకు?
చేస్తున్నారు సార్.
పీపీటీస్ తో పాటు ఇచ్చారు సార్. పీపీటీస్ తో కూడా ఇచ్చారు సార్.
పీపీటీస్ ఎవరు ఇచ్చారు?
క్యాడ్ క్యామ్ కూడా
మేడం ఇచ్చారు, రాజలక్ష్మి మేడం కూడా ఇచ్చారు సార్.
బాలకృష్ణ సార్ ఇచ్చారు.
ఓకే, సో ఇఫ్ యూ వాంట్ ఐ విల్ ఆల్సో షేర్ ఇట్. ఇట్స్ నాట్ ఏ ఇష్యూ, పీపీటీలే కదా. సో మేబీ సాయంత్రానికి లోపు మీకు వస్తాయి చూడండి. అయితే సాయంత్రం రేపో నేను షేర్ చేస్తాను, ప్రాబ్లం లేదు.
ఓకే సార్.
క్లాస్ రూమ్ లోనే పెడతా,
థ్యాంక్ యూ సార్.
క్లాస్ రూమ్ లోనే పెడతా నేను. క్లాస్ రూమ్ చూడండి.
ఓకే సార్.
ఓకే థ్యాంక్ యూ.
అయ్యే మనకు డౌట్లు అంతేనా? అది తీసి ఇప్పుడు ఆ మెటీరియల్ తీసుకెళ్ళి అప్పుడు ఓపెన్ చేసి చూస్తే అప్పుడు ఏమైనా డౌట్లు వస్తాయి, అంతేనా? ఇడే సుమంత్ ఏదో అడుగుతుండు, స్టార్ ఏదో పెట్టాడు. థ్యాంక్ యూ సారా. ఓకే, సో మెటీరియల్ ఇస్తాలే. అదే ఇంకోటి, మీ దగ్గర నేను వీడియోస్ షేర్ చేయమని చెప్పే కదా, నేను ఒకసారి చెక్ చేసి అది కూడా చేయండి అందరా.
సార్
ఓకే సార్.
ఆ వీడియో ఏంటంటే వీడియో షేర్ చేయండి మస్ట్. జస్ట్ మెయిల్ పంపిస్తే ఒకసారి నాకు యాక్సెస్ అవ్వట్లేదు డౌన్లోడ్ చేయడానికి. షేర్ చేయండి, నేను డౌన్లోడ్ చేస్తాను. అండ్ అది ఎవరికి వస్తుందంటే క్లాస్లో ఫస్ట్ ఎవడైతే నాకంటే ముందు లాగిన్ అవుతారో చూడండి వాళ్ళకి వస్తుంది. అది ఆ రోజు కొన్ని రోజులు అట్లా జరిగింది. మేబీ నాకు తెలిసి కిరణ్ సాయి వీడు పంపించాడు, ఒకటి పంపించాడు. ఆడొకడు సుమంత్ ఒకడు, ఇంకొకడు ఎవరో ఉన్నారు అట్లనే. రోల్ నెంబర్ 15 అనుకుంటా, నాకు కరెక్ట్ గుర్తు 15 అనుకుంటున్నా నేను. నువ్వు ఒక మెయిల్
రాలేదు సార్. అంటే
నువ్వేమైనా ఫార్వర్డ్ చేసావు? మెయిల్ చూస్తా ఉండే
నాకు. అంటే మీరు అప్పుడు
ఎవరో ఒకరు పంపించారు, కానీ అది డౌన్లోడ్ చేయడానికి నాకు వీలు అవ్వట్లేదు, డౌన్లోడ్ అవ్వట్లేదు నాకు. ఎందుకంటే సో యు ఆర్ నాట్ ద ఓనర్ ఆఫ్ దట్ వీడియో అన్న వస్తుంది నాకు. అంటే అడ్మినిస్ట్రేటివ్ ప్రివిలేజ్ రావట్లేదు నాకు దానికి. సో అందుకని
ఓనర్ అదే ఎడిటెడ్ రైట్స్ చేంజ్ చేసి పెట్టాలి సార్. అది
అట్లానే చేయొచ్చు, లేదా షేర్ అనే చేయొచ్చు. షేర్ చేసినా ఓకే, షేర్ చేసినా వస్తుంది.
లేకపోతే వీడియో డౌన్లోడ్ చేసి పెట్టమన్నారు.
షేర్ చేస్తే రాదు సార్, మాక్సిమం
అయితే ఎడిటర్
రావట్లేదు సార్.
కిరణ్ సాయి ఇది ఎవరు రా బైనా వాట్ ఈస్ దిస్ క్లాస్ వీడియో రికార్డింగ్ అని ఫార్వర్డ్ చేశాడు.
సాయి తేజ సార్.
సాయి తేజ నంబర్ ఎంత ఉందా క్లాస్ లో?
LG2 సార్, సాయి తేజ.
ఇది వచ్చిందిలే, ఇది డౌన్లోడ్ చేసి నేను ఏదో రకంగా డౌన్లోడ్ చేసినట్టున్నది. సో అది కాదు, ఇంకా చూద్దామండి. ఇంకొకటి ఎవరో ఉండి ఒక్క నంబర్ ఉంది ఇంకెవరిదో. ఎస్పెషల్లీ September 6th 7th అది రికార్డు వాడి దగ్గరికి వెళ్ళింది, అది వీడియో రికార్డింగ్. అది నాకు రావట్లా, రికార్డ్ చేసినా రావట్లేదు నాకు. అది నేను డౌన్లోడ్ చేయడానికి రావట్లా. నేను ఏదో రకరకాలు ట్రై చేసే కానీ బట్ స్టిల్ ఐఎమ్ అనేబుల్ టు డూ డౌన్లోడ్ ఇట్. September, okay, August, in August I think, September 6th exactly, if I remember it correctly. Yes, September 6th it is there. 7th, okay. Yes, what is this? I'll see. This also I think I am unable to download this one also. Okay. Okay, anyway, so you check your Google Drive. If it is there now, you forward it later. Otherwise, okay, I'll also leave it now. It's not an issue. So whatever available, I will take that and I'll submit it. So later, if you want to see those videos now, if you come to the college, if you want to see some of those videos, then you can come to the college. You can see it. It's not an issue. But only thing is the restriction is they are not shared publicly. If you want to watch all those videos, so whatever available with me, I will you can use my laptop or my desktop here. You can, if you want, you can watch all those videos also. But it is not going to be shared on the public platform. That is the only thing. So and also one more request is those who are having videos with you now, so don't play with those videos. So మీ కావాలంటే చూడండి, క్లాస్ చూడండి, మీ క్లాస్ వాళ్ళ వరకు షేర్ చేయండి కావాలంటే కావాలనుకుంటే, కానీ సో డోంట్ సెండ్ దెమ్ టు ద అవుట్ సైడ్ ఆఫ్ యువర్ క్లాస్మేట్స్. సో దాన్ని బయటికి వెళ్ళి మళ్ళీ దాన్ని ఇంకా వేరే చేయకుండా దాన్ని అట్లా చేయకుండా ఉండండి. సో అందుకని ఏం చేస్తానంటే నెక్స్ట్ టైం నుంచి ఈ ప్రాసెస్ లేకుండా ఏంటంటే క్లాస్లోకి ఫస్ట్ నేనే ఎంటర్ అయ్యేటట్టు లింక్ డిజేబుల్ చేసి పెడుతున్నాను. మీకు 5 minutes బిఫోరే లింక్ ఓపెన్ చేస్తారు రోజు నెక్స్ట్ క్లాస్కి. ఎప్పుడన్నా మర్చిపోతే మళ్ళీ అట్లా లాగిన్ అవుతారు మీరు. ఒక రోజు మర్చిపోతున్నా డిజేబుల్ చేయడం నేను. సో డిజేబుల్ చేస్తే ఏంటంటే మీకు 5 minutes బిఫోర్ లాగిన్ అవ్వడానికి ఫస్ట్ నేను లాగిన్ అవుతా, దెన్ ఓన్లీ యూఆర్ గోయింగ్ టు లాగిన్. సో నాకే రికార్డ్ అయ్యి నాకు వచ్చేస్తుంది ఆటోమేటిక్గా, మీకు ఎవరికి రాదు. సో దానివల్ల అడ్వాంటేజ్ ఏంటంటే మీకున్న స్పేస్ మీదంతా డేటా అయిపోకుండా ఉంటుంది. రికార్డ్ నాకే వచ్చింది అనుకోండి, ఇది కాలేజ్ వెబ్సైట్, కాలేజ్ డొమైన్ కాబట్టి కాలేజ్ డొమైన్ డేటా ఇట్స్ నాట్ ఏ ప్రాబ్లం. అట్లా కాకుండా మీరు ఫస్ట్ లాగిన్ అవ్వడం వల్ల ఏంటంటే మీ దాంట్లో రికార్డ్ సేవ్ అవుతుంది. రికార్డ్ సేవ్ అవటే కాదు, దాన్ని అప్లోడ్ కూడా అవ్వాలి, గూగుల్ డ్రైవ్కి అప్లోడ్ అవ్వాలి. గూగుల్ డ్రైవ్కి అప్లోడ్ అవ్వాలంటే నీకు డేటా కన్జ్యూమ్ అవుతుంది. సో మీకు డేటా వేస్ట్ అవుతుంది దానివల్ల. అందుకని అంటే ఇవన్నీ అవాయిడ్ చేయడం కోసం ఎందుకంటే నేను క్లాస్ లింక్ కావాలంటే డిజేబుల్ చేస్తున్నా. సో క్లాస్ స్టార్ట్ అయ్యే 5 minutes ముందు ఎప్పుడప్పుడు మళ్ళీ ఎనేబుల్ చేస్తా, దెన్ అప్పుడు జాయిన్ అవ్వండి. సో దానికంటే ముందే నేను ఓపెన్ అవుతా కాబట్టి, నేను లాగిన్ అయి ఉంటా కాబట్టి ఏదైనా రికార్డింగ్ ఉంటే నాకే వస్తుంది. ఇన్ కేస్ బై ఛాన్స్ ఏమైనా నేను మర్చిపోవడం ఏమైనా జరిగినప్పుడు మీకు వచ్చినప్పుడు ఏంటంటే నెక్స్ట్ టైం ఆన్వర్డ్స్ ఇమీడియట్గా దాన్ని నాకు ఫార్వర్డ్ చేయండి లేదా షేర్ చేయండి. సో ఓకే, సో ఓకే, ఈ జనరల్ థింగ్స్ ఓకే. ఎప్పుడుండే మనకి సబ్జెక్ట్ గురించి ఎవరు అడగలేదు, నా బాధ అది. ఒకటి కూడా డౌట్లు అడగట్లేదు, ఏం అడగట్లేదు. సో మరి మీరు ఎగ్జామ్ రాత్రో రేపు నాకు అర్థం కావట్లేదు. సో వాట్ ఈస్ ఓకే, ఈ డౌట్స్ అడిగితే ఓకే, ఫస్ట్ డౌట్స్ అడగండి. డౌట్స్ అడగకపోతే జస్ట్ యూ టెల్ మీ వాట్ ఈస్ యువర్ ఒపీనియన్. సో హౌ యు ఆర్ గోయింగ్ టు ఫీల్, హౌ యు ఆర్ ఫీలింగ్ గోయింగ్ టు ద ఎగ్జామినేషన్. ఎగ్జామ్ రాయబోవడం రాయాలి కదా నెక్స్ట్ వీక్. సో ఎగ్జామ్ రాయడానికి ఇన్ వాట్ సిచ్యువేషన్ యు ఆర్ దేర్. సో ఈ సబ్జెక్ట్ చూస్తే భయం వేస్తుందా, లేకపోతే పర్లేదు బాగానే ప్రిపేర్ అయ్యి బాగానే రాయగలం అనే కాన్ఫిడెన్స్ ఉందా, ఏంటి, వాట్ ఈజ్ యువర్ ఒపీనియన్?
సార్ ప్రజెంట్ అయితే కొంచెం భయం వేస్తుంది సార్. పీడిఎఫ్ వచ్చింది, ప్రజెంట్ అయితే కొంచెం భయం వేస్తుంది సార్. కానీ ఆ పీడిఎఫ్ వచ్చిన తర్వాత అట్లా ఒకసారి చూసుకుంటే మళ్ళీ అప్పుడు మారదు కదా.
ప్రజెంట్ అయితే భయం వేస్తుంది, అది చూడగానే వచ్చేస్తుంది అంతా.
అంటే చూడంగానే వచ్చేస్తాను
అంతా కాకపోయినా కొత్తగానే వచ్చేది సార్ అది.
అంటే కొంచెం బెటర్ కదా సార్.
ఓకే, ఐ విల్ స్టాప్ రికార్డింగ్.